Okay. So, we're going to start at the top. This is day 1 of 3.4. There's actually we're going to do quite a few days, but this is like a 2-part lesson, and tomorrow will be combinations. So a permutation is how many ways you can select things out of a certain number of choices, and order matters. So how many different ways are there to fill in the top row of a Sudoku grid? Now, we've played Sudoku before, right? The top row, tell me the rules. One of each number, and how many spaces are there? 9. So zeros are not involved, right? Okay, so we're going to write down 9 spaces. We're going to put multiply signs between them. You're definitely going to want a calculator for this if you don't have one. Okay, so how many choices are there for the first spot? 9. And how many for the second spot? No, because you can't have the same number again, right? So now there's 8. And then? 7, 6, 5, 4, 3, 2, 1. All right, so go ahead in your calculator and put in 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Yes, there is, and I will be happy to show it to you in just a moment.
Like when you press the on button, just like a dull black square pops up. Like it doesn't.
Hmm.
Should I just grab a new one?
Yeah. Battery burst in it. Battery acid, that's fun. All right, so what did you get when you multiplied 9 times 8 times 7 times 5, etc.? Say it again.
362,880.
Okay, so that's a lot of different ways you can get a row in a Sudoku thing. Can we all agree that, has anybody ever thought before looking at a Sudoku puzzle, how many different ways are there actually to solve this? You know, how many ways could there possibly be? That's just how many ways there are for the top row. Okay, there's a lot of different ways a Sudoku puzzle could work. So, this is also something called a factorial. This is 9 factorial. So 9 factorial is essentially equal to this right here, 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. It looks like a 9 with an exclamation point after it. So I'm going to show you how to do that in your calculator. Everybody put in the number 9 and then hit the math button. Go over to the one that's all the way to the right. It is probability. And do you see how the fourth one down is like an exclamation point? So 9 exclamation point 9 factorial. Okay. Which right now you're like, does that really save me that much time? Compared to writing 9 times 8 times 7 times 6 times 5. It doesn't, but I will tell you that it is definitely saving you time when it becomes like 42 factorial, for sure. And it will be. Okay? You look confused. You look confused.
No.
Did you find it on your calculator?
Yep.
Okay. All right. I'm gonna write down, this is 9 factorial. And that this was in your calculator under math, probability. For me, it was number 4. What's yours? 4? Okay. Find the number of ways you can type in a 4-digit code with no digits repeated. All right. Somebody want to tell me what to do? Yes?
So since so if it's going like 0 to 9, so there'd be 10. So you can do 10 factorial.
Well, you can't really do 10 factorial, can you? Because this would be 10 times 9 times 8 times 7.
Oh.
Because there's only 4 digits in the code, right? We don't need the other ones. Can anybody actually tell me what this would be? We could do 10 factorial on top. Now imagine having like 10, 9, 8, 7, 6. I don't know why I started this far over, but I did. Okay. So there's all the stuff on top, but what do I want to get rid of out of here? I want to get rid of the 6 and the 5, the 4, the 3, the 2, the 1, right? Do you see how if I put that on the bottom, that would cancel it out? And I'd be left with what I want. So what could I put in my calculator to make this work? The top is 10 factorial, right? What's the bottom? Everybody try in your calculator, try 10 factorial divided by 6 factorial. You get 5,040, which is what you would have gotten if you had multiplied those top numbers together. Now, I think we can all agree that multiplying those top numbers together is a lot easier than writing 10 factorial divided by 6 factorial, right? But it does help us actually come up with the equation we want for what a permutation is. And I want to match it exactly with what the book says. There we go. All right, so a permutation is NPR where N is like all the choices you have, and R is how many you want. So this is a permutation, NPR. So you start with n factorial on top. That's like 10 factorial, right? So this one would have been 10 permutation 4. Because I had 10 choices to pick from, but I only wanted 4 of them. And I do care about the order because it's a code, right? There's not going to be any kind of like 4-digit code that you're going to type in to get into like your car or get into your garage or something where it's just like, hey, type in these 4 numbers in any order. It doesn't matter. Like, it does matter what order you type them in. NPR, n factorial divided by, can anybody tell me how to get this from R? Subtracting it from the main. So let's use it with n's and r's. So
like n factorial.
Almost. The n factorial is on top. N minus r factorial, yeah. So it'd be like 10 minus 4 factorial, which is 6 factorial. And that's the formula for a permutation. So I'm going to show you how to use it. A psychologist showed